Good day, my name is Sierra Johnson. My partner is Angela Tia. Our teacher is Kofi Antwi. Our graduate is Yusuf. Our project is wireless network system for grid with node and in-station development for remote sensing. Our project goals is to design a Wi-Fi microcontroller applicable for microgrid, send a Wi-Fi signal over extended distance, and to establish peer-to-peer communication between an access point and a workstation. Introduction. So with the rise of wireless technology, human life has become very convenient, so much so that they can get anything with a tap of their finger within days or even seconds. The Internet of Things. The Internet of Things is a system of interrelated devices that sends data over a network without human-to-human or human-to-computer interaction. This interaction is very important because that way people don't have to sit at a computer and send data to another computer. This research is focused on developing a wireless communication system that uses a Wi-Fi microcontroller and in-station to send data to each other. Now, for the microcontroller to survive in a remote location, it needs a sustainable energy source such as a battery and solar panels. Powering Arduino using solar panel. So our accomplishments were that we were able to build a solar photovoltaic PV for short and battery smart controller. If you look in the top right corner, it shows our completed design for the smart controller. And we was able to connect the solar panel to charge the battery and use Arduino to prevent the battery from overcharging. And if the battery dropped too low, we was able to recharge it. And the picture in the bottom right shows our circuit design. Establishing connection between Bluetooth and mobile device. So in this part of our project, we was able to get a connection between the Bluetooth device and our computers, phones, and Arduino Nano. The picture in the top right shows our Bluetooth design, and the picture at the bottom right shows our code for the Bluetooth device, and the pop-up window is our serial monitor that shows the data that the Bluetooth device was sending. Arduino program for temperature measurement. So this part of the project, we were able to collect the temperature data from inside the room by using a thermistor sensor. And if you look at the top right corner of the slide, you'll be able to see the completed design with the thermistor sensor implemented. Peer-to-peer communication. So this slide shows that we were able to accomplish our project goal that we set out to do, which was the peer-to-peer communication between the access point and the workstation. The computer on the left shows the data receiver, and the computer on the right shows data transmitter. As for what was being transmitted during this connection, my partner will go into more details about that.
So on the right side is the server station. So the server station will be in the field, and then the access point will be in the building to get the data from the field. Peer-to-peer communication. So this is the results from the lab. As you can see, you get the temperature from the wireless station, and then you can actually see it having like a list. And then this is the flow chart for both the transmitter server station and the receiver. And yeah, this is. And then peer-to-peer communication. So in the top picture, you see this wireless station, and in the bottom picture, you see the access point. And we were able to maintain a communication signal from the workstation access point for about 500 feet. Adding sensors. So we added the light sensor to our peer-to-peer communication as
for the lesson activities, I'm trying to get my students to learn how Wi-Fi works in regards to how they function, the distance as they go. So for using geometry in circles and trigonometry, you're going to determine the range of Wi-Fi, and also you're also going to use trigonometry to calculate the resistance in circuits and determine the wavelengths of different communication. Also, you're going to measure how Wi-Fi travels if there's barriers in regards to, like if there's a metal or if there's a building, how they travel in regards to the distance that it can go.
In conclusion, we built a solar PV battery smart controller. We also built a hardware software Bluetooth system using Arduino for a smart charge controller. We designed and built an Arduino-based peer-to-peer wireless network. For our field test, we were able to maintain a communication signal between both the workstation and the access point for 500 feet. For future works, we're trying to get a better antenna for 1 mile data transmission. We also want to obtain a peer-to-peer communication over 1 mile, and we're also trying to add more sensors in the future. Thank you.